Welcome back to my channel. This is Good So, and what I do here is solve technical drawing problems and also provide very important information that can make use of for you to have better performance in your technical drawing examination. Your technical drawing student, please subscribe to this YouTube channel, put on the notification bell, and help me to share my videos with your friends who are technical drawing students. So right now I'll be showing you how you can determine the vertical trace and the horizontal trace of this line, and how you can find the true length of this line in both the auxiliary elevation and also the auxiliary plan. So let's go and look at what we need to do here. And as we have here, distance from here to here on this XY line is 82 millimeters. Distance of end A from XY line is 50 millimeters, and distance of end B2 from the XY line here from here to here is 12 millimeters, and distance of end A1 here from the XY line is 76 millimeters, and distance of end B1 from the XY line is 38 millimeters. And these lines, these views, they are given a third angle orthographic projection, as you can see the symbol here. So let's go and look at what we need to do. So the first thing to do is to draw the XY line. So draw the XY line. So draw a line like this. So this is our XY line. So this is point X and this is point Y here. So the next thing to do is to fix a point here. So fix a point here. And actually I'm drawing half of the given dimensions. So instead of 82, I will take 41 millimeters. So this is 41 millimeters here. This is 41 millimeters. Then I will draw a vertical line. I draw a vertical line. So draw a vertical line like this. So first of all, I will draw the front elevation, which is A1, B1. So point A1 is 76 millimeters from the XY line, and that will give us 38 millimeters. So I will take 38 because I'm drawing half of it. So this is 38 millimeters. So this is point A1. And also, so point B1 is 38 millimeters from the XY line, and that will give us 19 millimeters if I'm drawing half of that. So this is 19 millimeters, and this is point B1. Okay, this is B1. So I will join A1 and B1 together to obtain the front elevation of the line. Okay, so this is the front elevation. And also for point B2 or A2 is 50 millimeters from XY line. So I will take 25 millimeters as half of that. I will take 25 millimeters. So this is 25 millimeters here. And we have that. If you look at what we have here, we have point B2, it's below the XY line here. So it is 12 millimeters below the XY line. So instead of 12 millimeters, I will take 6 millimeters. So actually this is point A2 in the plan. So this is A2. Okay, so I will take 6 millimeters down here. So this is 6 millimeters, and this is point B2 here. Okay, so I will join A2, B2 together. A2, B2, I will join them together like this. Okay, so we have drawn the elevation and also the plan of the line. The elevation and plan of the line. Before I move on, I need to do something here. So I will draw a horizontal line from B to here. Draw a horizontal line from B to here, like this, to this point. And this point is point C1 here. So that's point C1. And also for this, I will draw a horizontal line from point B to here, to this point. So this point is point C2 here. Very, very important. So we need to take note of that. Now, let's find the horizontal trace and the vertical trace of this line. So what I need to do to get my vertical trace, to get my vertical trace. So this line A to B2 has touched the XY line at this point. So whenever it touched the XY line, so I'm going to produce a vertical line. I'll produce a vertical line down like this, just with short dashes line. So it intersect this line at this point. So this point that we have here, so this point here, this point where this vertical line that comes down from the point of intersection of the plan, where it intersect XY line, so this point is the vertical trace. This is vertical trace, and to get the horizontal trace, so I will need to extend this. So I need to extend this, to extend the front elevation like this. I need to extend it. So, and then I will draw a vertical line from wherever this line intersects the XY line. So it comes down like this. And also I will need to extend the plan. I need to extend the plan like this. So they intersect at this point. So this point here is the horizontal trace of the line. So this is the horizontal trace of the line. Okay, so we have obtained the vertical trace and the horizontal trace of the line, as you can see here. So the next thing to do is that we want to find the true length of the line. The true length of the line, which will serve as the auxiliary plan and also the auxiliary elevation. To obtain the auxiliary plan, so what I need to do is to take my protractor. To take my protractor, I will put it at point A in the elevation. Put at point A in the elevation. So let me draw it to this side. So I just set it here like this. Set it at point A1, and then I will put a dot on 90 degree. So we need to draw perpendicular lines. That's what I'm trying to do. So based on what I've done before. And also I'll put at point B1, so I put at this point. So then I will draw a perpendicular line to point A like this, and I will also draw it to point B like this. Sorry, this is point B. Okay, so I'll draw a perpendicular line to it through this point. Alright, so the next thing I'm going to do is to set my set square on line A1, B1 to obtain the auxiliary plan. So I'll set at this point, and I will shift it to any distance that I like. So shift to any distance. So I will join this together like this. Okay, so this point here, so this point is point B3, and this point is point C3. Okay, point C3. So the next thing I'm going to do is to take my compass. So I will now take a distance C2A2, A2C2 in the plan. So that's what I'm going to use. So I'll take this distance like this, and I put the pinpoint of my compass at C3 here and make an arc here. So this is point A3. So I will join A3, C3 together to obtain the true length. So this is it. So this is the true length of the line. This is true length of the line. Then to obtain the true length, it is the true length and also the auxiliary plan of the line. So the next thing I'm going to do is that I want to obtain the auxiliary elevation. So I need to draw a perpendicular line to point A to here. So for me to do that, I need to make use of my protractor. I'll put a dot here and also put it at point B2. So I put a dot on this 90, then I will draw a perpendicular line to this point, and also I will draw it to this point like this. Okay, so next thing I'm going to do is to take my set square, set it at this on this line A to B to here, which is the plan. Then I will shift it to any distance that I like. So this is okay for me like this. So this point here, this is point B4, and this is point C4. So I will now take distance A1 C1 here. I'll take distance A1 C1 in the front elevation here. So I take this distance like this. So now I put it at C4 here and make an arc here. So this is A4. So I will join A4 C4 together. Sorry, A4 B4 together. A4 B4 together like this. Okay, so this is the true length, and it is also the auxiliary elevation. It's also the auxiliary elevation. So I want to determine the true length, so I just take this measurement. I want to measure it. I want to know if the true lengths are equal. So this is 56. This is 56 millimeters. So if I take this measurement also, this is also 56 millimeters. So it means the true length are equal, and also the work that I did is correct. So all you need to do is to practice it. I've shown you how you can find the horizontal trace and vertical shape of the line when lines are given in this form, and how you can find the true length of the line. Keep on practicing, and God bless you.